So the final part in our discussion about kind of math skills that we need in science is about equations. In the first couple of parts, we looked at measurements and how to record measurements in terms of scientific notation or standard form. Then we looked at different units that we can use. And so that's just a matter of getting the numbers. What we do with them after that usually involves some sort of equation. Now, sometimes we can get numbers just by recording using some sort of instrument, like use a meter stick to get a distance, and you use a stopwatch to get time. But other things, it's easier to get those, and sometimes only possible to get them using equations. For example, I might see somebody driving down the street just before they get in an accident, and I'm being interviewed by the police, and I could say they were going fast. Well, what does that really mean? What does going fast mean? Going fast down Homer Watson is different than going fast on the 401, and it's different than going fast on a short cul-de-sac in a residential neighborhood. So what fast means is it's qualitative. And for me to say how fast the person was going quantitatively would be almost impossible because I can't see their speedometer, and I probably don't have a radar detector with me. So I might be able to, however, if I have a stopwatch and if I know the distance between two street lamps, then I might be able to calculate what that time is. So we use formulas to do that. And sometimes the formulas that we use aren't necessarily in the form that we want. I want you to think of this, especially if you think to yourself, oh, well, math, I'm not really strong at math. I think that's just a mindset that we can start to get over if we think about things in maybe more familiar terms. So think of math as a language. It really just is a language of describing things, maybe a little bit more specifically than the rest of our language. So, and just like in the English language, we have 26 letters to make up the alphabet. There are symbols that we can use to, or variables in science that we can use to describe things as well. So some of those variables, let's look at things you would have looked at in grade 9. We might have talked about mass, M. We might have talked about volume, capital V. We might have talked about current, capital I, or resistance, capital R. Voltage, which is also a capital V. And then so it gets a little bit confusing when you start using the same letters for different variables. But there are many different letters. Some of them even use Greek letters instead of our regular letters that we use in English. When you put those letters together in a language, you get words, and they take on very specific meaning. And you can't just randomly smush together a bunch of letters. Like, I can't make this formula where I say M equals V times I. That's not going to work. I can't just choose which letters go together in the same way that I can't just put like QVR and say, hey, that's a word. Neither one of those things makes sense. So the equations that we get come from very specific places. I talk about that a lot in grade 11 physics course, and we don't need to get into that in much detail. But they do come from places. And once we know what that equation is, and so maybe density equals mass divided by volume. You might have seen that in grade 9. You might have seen resistance is equal to voltage divided by current. In math, you might have seen y equals mx plus b. All of these have very specific meanings and can help us analyze a situation very specifically. But I can't, if I want to rearrange these letters, these variables, there's only certain ways I can do it. In the same way that if I want to make new words, there's only certain ways that I can mix up those letters. Now, the big difference here with my analogy is that if I have a word like, for example, cat, I can rearrange that cat word to make the word act, but I can't rearrange it to make it act. It doesn't make sense. So in that way, it's a lot like our equations. However, there are some words that don't rearrange at all, and the word cat and the word act have nothing to do with each other. When we're looking at equations, however, when you rearrange an equation, you still essentially have the same equation. You're still saying the same things. You're just looking at it from a slightly different perspective. So, let's look at some of the examples that we had up above. If we say D equals M times V, or M divided by V, that's a definition for density. It comes from what density actually is. We know what density is. It's a mass per unit of volume, and we get an equation from that. Well, what if I want to use that to calculate mass instead, where I know the density and I know the volume? So basically what we're doing is we're trying to isolate the variable m. We're trying to leave it by itself on one side of the equation. And the way we do that is by basically performing BEDMAS, which you would have done in grade 9 and possibly before. What we do BEDMAS kind of backwards. Well, in this case, remember the BEDMAS: brackets, exponents, division, multiplication, and addition and subtraction in the order they occur. We would start in BEDMAS with doing brackets and exponents when you're going to solve something. Well, this is opposite. So we have to look at any addition and subtraction that we would do first. And there is no addition and subtraction in this question, so I don't have to worry about it. So let's go to division and multiplication. Well, there's definitely division. Well, I want to get V away from M. I want to isolate M, leave it all by itself. So if I'm going to do V away from M, you got to look at what we're doing in the equation here. V here is being divided. We're taking M and then we're dividing by V. So in order to kind of get rid of V or move V over to the other side, I'm multiplying both one side by V. And that's going to mean I have V divided by V, which is 1, so they kind of cancel each other out. But whatever I do to one side of the equation, I have to do to the other side to keep it fair. Remember, the equal sign means an equality. Whatever I do to one, I have to do to the other. So what we're going to be left with is D times V, and I would normally write that as just dV equals M. So I have isolated M. What if I want to isolate V instead? So if we start over with this original equation, D equals M divided by V, I can isolate V by dividing by M on both sides, but the problem is V is going to be in the denominator on the right side of the equation. So if I did this, if I divided by M, which means M divided by M is going to cancel, I divided by M on that side, I'm going to get D over V equals, or D over M I should say, D over M equals 1 over V. I don't want 1 over V, I just want V. So the better thing to do, forget all of this, just cross that out if you want. You don't need to take the time to erase it, just cross it out. I should start with this equation. Maybe I do this in 2 steps. So the first step I do is to get V on top by changing the side of the equation that it's on. Bring it from the right side to the left side by multiplying both sides by V. Now I'm going to take that and I'm going to divide both sides by D now, because the D is the variable that's with V that I don't want. So I want to isolate V. So I'm going to divide both sides by V. That's going to cancel, and I'm going to get V equals M divided by D. Some of you may have seen this in what's called a right triangle. Looks like that. You've got M on top, and you've got D and V on the bottom. This line represents divided by, this line represents multiplied by. I usually tell my grade 9s, if they happen to see it, I never teach it, and I'm going to explain why in a second. I usually tell my grade 9s, use it if you plan on never, ever, ever doing any math ever again in your life. And that kind of limits things, because most people are going to do some things that involve some math. And so being able to rearrange an equation and understand why it works is quite important. And I'll come back to the big problem I have with the triangle in just a second. So I'm not going to go any further on that, except to say that that is an absolute last resort. I call it a crutch. If you constantly use the crutch, you don't get any stronger. And so let's look at the R equals V over I is basically the same thing. So let's look at the Y equals MX plus B, and that will kind of prove my point about the triangle. So if I have Y equals MX plus B, and I want to isolate m. I'm going to calculate m based on y, x, and b. So m is not by itself, so I need to isolate it. Now how am I going to do this? Again, we're going to do bedmeth backwards. So the first thing I want to do is add or subtract anything that doesn't have an m in it. So in this case, it means my b. I'm going to put this in green here. So I'm going to subtract b on both sides. I'm going to have y minus b on one side, and I'm going to have mx plus b minus b on the other. And you'll see that the b minus b gives you 0. So they essentially cancel each other out, and what you're left with is y minus b equals m times x. Now that you have that, if I want to get m by itself, now I have to deal with x. There's no more addition and subtraction to do. I just need to deal with x, and right now x is being multiplied on this side, so I need to divide it, and I need to divide it on the other side as well. Very, very important that that line goes through the entire thing that's on the left-hand side. In this case, y minus b. So I have y minus b over x. The x's cancel out here. So what I'm left with is m. And it doesn't matter which side of the equation of the equal sign you put it on. I have m by itself, and on the other side I have y minus b, all of that divided by x. So when I'm plugging this into my calculator, again, very important that you know how to use your calculator properly. I plug in y minus b, press enter. That gives you your numerator, and then divide by x. If you plug in y minus b divided by x, exactly like that, you're going to end up with the wrong answer. So notice that in what we did over here, there is no rate triangle that you're going to be able to use that will do all of these steps for you. So if you don't understand what you're doing up here and just jumping to this little triangle thing, then this is going to cause you a huge amount of confusion. So I would suggest not using this at all. Stay away from it and just learn what you need to learn in order to be able to do any of these equations. That's about it. There's some practice for you to work on, and we're going to see a number of equations in this unit. You definitely see a lot of equations if you take senior level science, specifically physics, but also chemistry, and maybe even a little bit in biology.